Okay, so last hour, I know it's been a few days since you went over the two reactions, so we did a little activity with that, but also you have a couple of things that you got to get done before Friday. So I want to make sure you have a little bit more time to deal with that. So we had some time, we spent some time with them writing up the reactions. Make sure you're good with the reaction. Our aerobic cellular respiration reaction. I'm going to put it up here as aerobic cellular respiration. Okay, what's one of my reactants?
H2O.
We got to do this together, otherwise we're going to stop and do a 20-minute review activity. Okay, do we need to do that?
No.
Okay, we need water. What else?
Oxygen. O2.
What else?
Uh,
Nutrients. What is my nutrients?
CO.
Which is what? Okay, so watch. This is my reactants. And I know some of you guys got confused with this last week when you said there was the terms reactants and reactions. In the writing the essays, you're going to have to talk about these reactions in terms of the reactants and the products. Okay, so it will take you a little bit of study and going over. Okay, what are my conditions for this reaction?
Right time.
Okay, so you have to have right enzymes and delta T, which I talked to you. I kept asking people, what does that mean? Okay, so what are my products? Carbon dioxide. What else? Some new water and how much ATP? 36 molecules of ATP. Okay, these are our products. What's our other reaction?
H2O plus.
What's our other reaction? What is it called?
Photosynthesis.
What is the purpose of photosynthesis? Make sugar in the form of what? Glucose for the plants. Who can use the glucose?
Everyone.
Anybody can use the glucose. Cool. So photosynthesis, right? So we have two reactants. What's one of them?
H2O.
H2O plus
CO2.
CO2. What's our enzyme?
Chlorophyll.
Chlorophyll is our enzyme, and we still have to have
Radiant energy.
good. Okay, radiant energy. Okay, so the overall output is
H2O plus C2 plus C6 H12.
so we're making water, we're making some oxygen, but ultimately we're making this glucose that we need to produce. Okay, C6H12O6. Now. We just made the molecule earlier, didn't get it filmed, but that's fine because you should have this, and you have the reaction in front of you. I want to follow the carbon. So there's a couple things. Somebody asked me, because it was on the learning target, about, oh, we learned that. There's three basic cycles you have to know. Nitrogen cycle, carbon cycle, and the water cycle. The water cycle is easy. Ready? Precipitation, evaporation, condensation, rain falls down. Okay, we're going to do this together. You ready? You do not need to learn about this because you did it in second grade. You ready? Get your sparkle fingers out. We're all doing it. We're all doing it. Mr. Adam, ready? Precipitation. Wow. Everybody at once. Precipitation. Evaporation. Condensation. Rain comes down. You got honey in your voice today, Chris. Sounding good, okay? Okay? That's the water cycle. It goes down, evaporates, condenses, goes down again. It keeps going. Now, the nitrogen cycle is a little bit different. It has to do with dead animals and animals going in the soil and going through it. Carbon cycle is a little bit weird. Marshall?
Open the door again. It's kind of getting.
Yeah, it's fine. Carbon cycle is a little bit different, okay? I want to tell you a little story that goes along with the carbon cycle that'll help you notice it. On the bottom of your map, look at the bottom of your thinking map. You see where it says carbon cycle. Okay, I want you to look at this. Don't do it now. And also, I was like circling and doing stuff earlier, and people just staring, and I go, did you write it down? I go, like, no. And I go, I already know this. Why am I writing it down? Do I need to write it down? Do I need to write it down? So you need to write it down. Okay, so watch. We did the molecule. We showed how many carbons are in glucose?
6.
6. So in glucose form, in a solid form, the carbons, because we just want to focus on the carbons, they're hanging on to 5 other carbons, and they're in a ring form. Now, once you go through we're going to go through what reaction to release ATP?
Aerobic cellular respiration.
All at once. We're going to go through what reaction to release the ATP?
Aerobic cellular respiration.
Why is it called aerobic? Yeah, we're not breathing. We're using what?
You need oxygen to break the bond.
That's going to break your bonds with the enzyme, and then you have an atom that, it's a carbon atom hanging on to two what?
Oxygen.
Oxygen atoms, and I'm now carbon dioxide. So I'm going to go between hanging on to my carbon buddies in a solid ring to being a gaseous carbon dioxide. So we can start anywhere you want, and I think we're going to start right here, and I want you to do this. We're just following that carbon. We're just following carbon. Bree, do you have this? I'm just following carbon, okay? Not the oxygens, nothing like that. So let's start with carbon. So there's carbon dioxide all around us, right? Most of what's around us is nitrogen. So we have to have a starting point. So go ahead and breathe in and out. When I tell you to go, Jose, when I tell you to go, I want you to breathe in and out. I want you to grab just one carbon. There's carbon dioxide all around here, okay? So we'll just breathe one out because we'll be done with it through aerobic cellular respiration. We'll just get one. Ready? When I say to go, everybody has to breathe. I can't do this by myself. Oh my gosh, it's going to be a long day. Ready? Breathe all at once. When I tell you to go, you're going to catch one of those carbon dioxide molecules. Ready? Ready? Go. 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 Okay, you got one carbon dioxide molecule, correct? Okay, that is a product from aerobic cellular respiration. We're going to focus on the one carbon. Let your carbon dioxides go. Just let them go. Let them go. Okay, watch. I can do it. Right there. Same one. Okay, back and forth. I can let it go. It's in your hair. Let go. Get out of here. Get out of here. Thank you. Okay, good. He was trapped. He was trapped. What am I going to do? Okay? So watch. I can let him go around this room and get any tricks. I want to focus on the carbon that is connected to two oxygens. Just the carbon. We're just looking at the carbon. I'm going to name that carbon Paco. Okay? Now watch. Now watch. I can let him go. If class breaks, basically, it's air. He's just moving all over the place. Watch. He just do flips. He can do everything like this. Watch. See that? Pretty amazing. They can do anything. They can go all over the place. I can let him go. When you guys leave this room, it'll get pulled out into the hallway. As the wind and air is moving and circulating, he's going to get pulled out in the breezeway out there. And then air is going to push through there and get pushed out in the parking lot. And as the day heats up and warms up, it's going to get farther and farther up in the atmosphere, right? And if you let it go for a couple weeks, and because he'll just sit there and move around. He'll just sit there and just float around. You let it go for a couple weeks as the sun keeps coming out each day, that air is going to get farther and push farther and farther and farther up in the atmosphere until you get to like 20, 30, 40,000 feet. Now, this is going to take a while. It's not going to happen in a day. But 2-3 weeks goes by, he'll get pushed up in the upper atmosphere, go at about 30 or 40,000 feet. Just above that is something called the jet stream. So if you guys ever watch the news and the lady talks about, we've got this jet stream coming through here. You know what I'm talking about? Jet streams are generalized weather patterns. They're high-speed wind patterns that are really high up, but they help to move weather. They move like 300 or 400 miles an hour. They're fast-moving wind. But if Paco gets pushed up there and he's hanging on to two oxygens and he gets pushed up in that jet stream, he'll start going around the world, man. That wind will just keep carrying him around the world. And he can do that 5, 6, 7 times, 100 times, who knows? It doesn't really matter. He'll just keep going around and around. Let's say he does 4 or 5 rotations around the Earth and just keeps going in that generalized wind pattern. He is still that one carbon Paco hanging on two oxygens, just woo, going around the planet, right? That could take 3, 4, 5 weeks, right? Until he bumps into something like a low pressure system somewhere over Kansas, right? That low pressure system is going to bring in rain. So let's say he's floating around that low pressure system above Kansas. Raindrop hits Paco as he's hanging on two oxygens, brings him down. Now he's over Kansas. He's over one cornfield in Kansas. And that one Paco molecule that's connected to two oxygen molecules falls down to the ground and lands on a corn plant, okay? Now that corn plant is going to take that carbon dioxide and use it for what process? Right? So let's follow this. This carbon, whoops, right here, that plant is going to use that carbon dioxide molecule, that Paco atom. It's going to pop off the two oxygens, and it's going to start connecting some other carbon dioxide molecules together in order to make what molecule? What's the purpose of photosynthesis? What's the purpose of photosynthesis? What's the name of the sugar? Okay, so that one plant is going to take that one carbon dioxide molecule, join it with other ones, until you can bring it together, and you've got a bunch of carbons connected together in that 6-carbon ring, right, in the form of glucose. Now, Paco is trapped hanging on to 2 of his carbon friends in one glucose molecule, in one corn kernel, in the middle of Kansas somewhere. And this is 6 to 8 weeks from now, right? Just sitting there. Now, farmer comes and harvests it, pops off all that corn, and he's going to have to sell it too. He doesn't do anything with that. He sells it to wholesalers. He sells it to a place in upstate New York. He ships all that corn up there. It takes 2 weeks to ship it up there. Goes to upstate New York. They take it and they grind all that corn into something called cornmeal. He is still hanging on to 5 other carbon atoms in the form of that glucose, and that solid glucose. And he's in this now cornmeal that's ground up, sitting in some silo of an upstate New York, right? And it's just sitting there. Now, by this time, we're at 3 months. 3 months from now, right? Could be longer, could be shorter, but that's a good time frame. Now, in upstate New York is another company called Frito-Lay, which you may have heard of, okay? And Frito-Lay buys that cornmeal. Paco is in part of that cornmeal, hanging on to the other carbons in the form of glucose. And he gets shipped over to this company, Frito-Lay, in that upstate New York. Now, Frito-Lay is going to take that cornmeal, partly of which Paco's in, and they're going to make one of the greatest snacks ever produced. Can you guess what it is? Frito-Lay?
What's that?
From corn. Close. Corn nuts. Greatest snack ever made. Who likes corn nuts? Who likes? Oh, they're so good. Best flavor? Ranch, by far. Undisputed best flavor corn nuts is ranch. Who has not had corn nuts before? Go get some ranch corn nuts. You take the corn nuts, you put it in your mouth, you suck off the ranchy goodness. Who's with me? Who's with me?
No.
You suck off all the ranchy goodness, then you eat the corn nut afterwards, okay? So now, Frito-Lay company takes that cornmeal that Paco is connected into one glucose molecule, makes them into corn nut. Now, Paco is connected in that glucose molecule in one corn nut in one bag sitting in this giant warehouse. We're now 5 months from now, right? Now, one of the weird things you don't know is what happens over time is things that sometimes become popular in the United States, for whatever weird reason, they could have been here for like 20, 30 years. Like that happens with like jeans and stuff like Levi's. Like Levi's have been here for like 50 years, and all of a sudden people in different countries go, we love Levi's, you know? And then all of a sudden there's a huge rush on Levi's in like Britain or something like that. You know, it's weird. Right now, #1 snack food in England, take a guess. Corn nuts. Why? I know, even me, I'm like, why? They're not that good. I like them too, but they're not that good. Corn nuts is like the huge thing in England right now, okay? So Paco is in that one corn nut, in that one bag of corn nuts, sitting in a warehouse that is now going to get shipped over the Atlantic, across the pond, okay, sent to England. It's going to get sent to a distribution warehouse in there. So now we're from 5 to 6 months, now we're almost a year out, okay? And then eventually, some store owner is going to take that bag of corn nuts, one of those corn nuts Paco's in the form of a glucose molecule, and he's going to put it in the storefront window. And some little 10-year-old boy is going to walk by and go, I'm going to get me some corn nuts. Okay, I don't know why they do this, but they do it, okay? Get me some corn nuts, right? They grab the corn nuts, he eats it, takes in Paco in the form of glucose, and uses it for what reaction?
PCR.
What's it called?
Cellular respiration.
So, this, once you here, Paco is now over here, and that's glucose. That glucose is then being used to process ATP and gets converted back into what again? Carbon dioxide. Remember, we are following the carbon, but that carbon gets changed between what 2 molecules?
Carbon and
No, the atom is carbon. The carbon gets changed, converted into what 2 molecules? What's this one?
glucose.
We're going from glucose to what?
Carbon.
Carbon dioxide, and then carbon dioxide goes back to what?
Glucose.
Glucose, and then it goes back to what? Carbon dioxide, then it goes back to what? And then it goes back into what? And then it goes back into what? Okay. And can the carbon, in all carbon isn't going to go through this, but if we followed Paco and it kept going through that, when would this stop?
Never.
It doesn't stop. It's a cycle. And here's the thing. Here's what I always think about. That one carbon atom, that one Paco atom, when he's like jammed on the 2 oxygens, he's floating around, a plant takes him, pops off the 2 oxygens, joins them up to 2 or other carbon atoms to make this solid form of glucose in a ring, which gets used later on in this aerobic cellular respiration. If we keep following that pattern back, we go back and back and back, he could have been using like Napoleon. Like that carbon, that Paco could have been in Napoleon. It could have been in a dinosaur. It could have been in birds. It could have been in plants. It could have been in anything prehistoric. It could have been all over the place. It never stops. That is a carbon cycle. That is way different than precipitation, evaporation, condensation. it's a little bit tougher cycle to follow than that, okay? However, if you go on the bottom of that box, go on the bottom, that bottom box, see where it says carbon cycle? Now, what we just went over was the carbon cycle. I call it the Paco cycle sometimes. Please don't ever, like when you're writing this out for a test, like you're doing the ACT and you're like, first Paco does this. Okay, don't ever, 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 ever do that. However, you now have a little visual in your head of like, I can follow this line, I can follow that carbon, and I have something to put on that carbon, and I can see where it goes and how it goes through that weird cycle, okay? You can call it the Paco cycle if you want. See where it says carbon, put underneath there Paco, okay? If you want, okay? But remember this, that always means the carbon cycle. Now, you have it fresh in your head. You need to fill out this little thing on the bottom. You are going to be asked, I'm going to give you questions that, my questions are a paragraph long. Okay? You're going to be asked to write a paragraph on it. I want you to spend about 4 or 5 minutes talking with your partner about, okay, what is this carbon cycle? What are we really following? How does it go from here to here to here? I'm going to go ahead and erase this too. Okay? This is not for you to see. You have it on your notes hopefully already. Any questions? Okay, go for it.